All right, so we are given here, we can actually define the relative velocity as the velocity of an object from the reference point of an object, which is the one that I was mentioning to say, as we consider the relative velocity, it's velocity of an object relative to what? Which is the most important part. Then another important part is the reference point, a place or object that is used for comparison to determine if an object is in motion.
Okay.
So let's say we are given an object. An object can be anything. Anything in our mathematical view, in terms of science, can be referred to as an object. Meaning to say, if let's say we are considering a person, we can consider a person as an object.
Yes.
We can consider a train, we can consider a car, we can consider any moving, any living, non-living can be referred to as an object. So the velocity that we have in general, we are going to start on a condition of the parallel lines when we are considering relative velocity, but on a condition where the movement is parallel.
Mm-hmm.
In that manner, we consider same direction, same movement, like in this way. Remember the condition of parallel lines.
Yes.
So if we consider that, we are going to notice that we have a velocity that is of the ground, that is referred to the ground, which is not going to change which is not going to change. It is going to be the same throughout.
Mm-hmm.
So as we have for the parallel, the velocity of the ground with respect to the ground.
Wait, excuse me, sir?
Okay, I'm saying as we have any movement that is going to happen for relative velocities along the parallel lines, we are going to notice that the velocity of the ground is one that we are going to be measuring in our calculations. We are going to be having this in our calculations.
Yes.
And as we are having this velocity, it is nothing, it is just a zero. There is no value that we have for that one as we consider the ground.
Oh, yes.
So it is the same for each and every part, each and every calculation that you are going to have.
Mm-hmm.
Equivalent what? To zero.
To zero.
Even our speed in meters per second, we're going to consider meters per second. If it is kilometers per hour, depending with what you're given.
Consider kilometers per hour. Yes.
So this one, it's always like that.
Yes. Okay.
So we want to consider this now to say, we might be given one point that we are referring to, and that point is the ground.
Mm-hmm.
That is our reference point. So meaning to say we can have velocity of an object A relative to the ground.
To B. Yeah.
We are still here on the ground.
Oh, yes. Sorry.
Are we together on that one?
Yes, sir. We're
So
together.
it can be velocity of A relative to the ground.
Mm-hmm.
That's the velocity of an object A relative to ground.
So, ground.
Okay. If we are having the velocity that is being referred back to the ground, and we are saying, what is it about the ground? It's zero. So it actually tells us this is the actual velocity in normal sense of what you are given on the question. The question will be giving you the velocity of A, the velocity of B, the velocity of a car, the velocity of a train. That velocity that you are given on the question. It means that is going to be our velocity of A with respect to the ground, or
Back
it's
to the
B with
ground.
respect, because there is no effect. The ground is what? Is at zero.
Zero. Yes.
So our
Mm-hmm.
normal calculation was supposed to be like this. Velocity of A with respect to the ground is equal to, you start with this A going to G.
The ground.
So it's
Yes.
supposed to be VA minus VG.
VG. Okay.
This is what we're supposed to have. VA minus this.
Yes.
But we noticed that VG is what? That's a zero, this one.
Mm-hmm.
So meaning to say, at the end of the day, we are saying our VAG, which is the velocity of A with respect to the ground, is equal to what? Is equal
VA.
to VA.
Yes.
So that is why we are saying the velocity of A with respect to the ground, whether it's the car with respect to the ground, the train with respect to the ground, that is the initial velocity that you are given, the actual velocity that you are given.
Mm-hmm.
It is the actual velocity that you are given.
Yes.
So meaning to say, once we consider now the ground to A, it is just the opposite. If this is of A, then when we say ground to A, it simply is going to be minus what? Minus A,
It is A.
minus VA.
Yes.
It's just an opposite. That one carries a negative. This is positive. If we change, even if there was A and B to be considered, let's say we obtained for A and B, then we want for BA. It's just the opposite of this one.
Mm.
So
Oh, okay.
that
Yes.
one, no matter the case that is, we just consider as the opposite. But let's say we wanted the formula is still going to be the same. Let's say we want velocity of the ground with respect to A. As we had this one, VAG, we said VA minus what? VG.
Yes.
So when it is like this, you're going to start with what?
VG
Exactly.
minus VA.
Minus VA. So that was
Mm-hmm.
going to be 0 minus this, which will end up with what? Minus VA.
Yes.
So are we seeing that still one and the same thing?
Yes. One and the same thing.
So that is what we are going to be having. So if we are dealing with the parallel lines, it is either we are having a movement in this manner, where either we are going to the east or to the west.
Yes.
There will be, the lines will be parallel, but the movement now can differ. To say someone can be going to the east, another one can be going to the what, to the west,
Yes.
but being parallel to each other. So it cannot be parallel while you are talking about west and we are talking about the north. No, it will be
Mm-hmm.
perpendicular now. We won't be
Yes.
having this. So this one, we're talking about when they are parallel, to say they are just in the same way or opposing each other. Both can be going the same way to the east,
Mm-hmm.
or it can be opposing. That is the manner of a parallel. Same direction or opposing that direction that you're given initially. So we are also going to consider that in terms of our direction when we are given, because they can tell us that it is to the east or it is to the what? To the west. So that part also plays a role in terms of the sign that you're going to use: to the east, positive; west, negative.
It's negative.
If it is up to the north, positive; down to the south, it is
Positive.
what? Negative.
Negative. Yes.
So in case that we are given the movement to say it is going to this direction, there the direction becomes the sign.
Yes.
Sometimes they don't mention about the direction. They just say maybe the car is moving forward. You know that forward, positive.
Mhm.
When they say backward, negative.
Negative. Yeah, those keywords is what I have
That
to
is
look out for.
exactly. That is the major part.
Yes, sir.
So let's say we have got A and B now. We want to use the same consideration and bring these formulas to one thing to one. They must give us one same thing. You were referring to a reference point as the ground, one reference point there. Now we have got 2 points A and B that we can work out from. But the
Yes.
two, A, remember when we refer to the initial part where we started about A, we say this is the actual, which is same as A with respect to the what? To the ground.
Yes.
Wherever we see VA with respect to the ground. Same with VB, whenever we see it, we are seeing what? B with respect to the ground.
Yes. It's the
Yes,
actual velocity.
exactly. So, but as we need to combine the two velocity of A relative to B, it's
Mhm.
going to be what? From this part, it was supposed to be A minus what?
B.
A minus B. So it's going to be VA minus VB.
Yes.
But what does VA represent?
VA represents the actual velocity.
What about VB? Actual
Actual
velocity again.
velocity to the ground. Yes.
So meaning to say VAB, someone can write this formula this way. Someone can write it this way, as long as you understand what you're writing.
Yes, sir.
It's one and the same thing that we are representing there. So in the same manner, we could have calculated of BA, B with respect to A or relative to A, as B minus
Yes.
what? As B minus A. That is the case that we are going to have. And
Yes.
also, so here I maintained the negative that we had from the beginning. We could have changed this formula to a positive, but let's avoid that. Let's just maintain one formula that has got what? A negative. You can manipulate that one to make any part the subject part. Let's use original starting with what? With a negative, then we can manipulate it from there. So these are the typical questions actually that you're going to have. So I'm not going to waste time coding to those questions that you are having from the textbook. I think it can be clear. It's clear actually. I'm just gonna choose one question, then you work out other examples. Then we see questions how they are given. But this first part, they can ask questions if you check. I think just try to check 2023 and 2024 questions.
Okay. I must check now.
No, just after when you're doing your
Okay.
revisions, if you check those ones, you can see
Okay.
that
Just hold on.
there are some questions which are basically on these questions that we are doing now, which is on basic
Okay.
parallel lines of our relative velocity moving on to the non-parallel. So this section is important, very,
Okay.
very important. So let's just have one, just one or two. Then there's another typical exam that we're gonna look into, but this one, it's not that much. Yeah, I'm just going to discuss one or two from that textbook. If you check the first example that we have there, I want us to consider there. If there's anything that you see that can be challenging, let's see it.
Uh, are we talking
Um,
about the examples or activity 1.1?
this one, the example first. I want to check on this one if there is any question that is there but not clear.
Okay. What number is that?
Uh, this one is supposed to be the first one.
Oh, my first one is a bit different.
The
If we talk
second,
about activity one.
so it's supposed to be second one. I think it's second one.
Oh, there's it. Yes, I can see it now. That's fine.
Okay, so on that one, I don't know if there's any question that can be difficult. You are walking due east at 10 kilometers per hour on a road parallel to a railroad. A train is traveling at 70 kilometers due east. At the same time, a car is traveling due west at 50 kilometers per hour. And the questions calculate your velocity relative to ground, velocity of the ground relative to you. I don't know if it is clear.
Yes, it is clear. Yeah, velocity, your velocity. So, okay.
Okay, that one is going
Yes.
to be what?
Oh, okay. So it's going to be at, okay, since it's me, I don't know if I should uh have a specific letter. So we can either say P for person, and then so it's going to be VP
Okay,
or
no
VU.
problem.
Okay, yes. Okay, so it says relative to the ground. So VP, yes, it's going to be VPG is equals to VP minus VG. Your velocity relative to the ground. Yeah, I feel like I'm correct.
So when they say this one relative to the ground is going to be what?
Yes, G. Then it's going to be VP minus VG.
Where
Yes.
VP, you east this one.
Yes, east, which is in the positive direction. It's going to be 10 minus 0. Yes.
So that will be 10
10 to
kilometers
the
per hour to the what? To the east.
east. Yes, sir. Because
So
the
this
ground
is
is equal to 0. Yes.
okay. So this is the same thing. The velocity of the ground relative to you, then you oppose this one, it becomes
Opposite.
negative.
Yes, it's going to be negative.
Okay, no problem. What about this one? The velocity here of the car relative to the ground. This one is gonna be clear. I
Yes.
need your velocity here relative to the car on E.
Okay. So it's going to be V PC, if since P is our person and C is our car,
Okay.
right? So we're going to say VP minus VC, and our car is traveling at 50 kilometers per hour, and our person is traveling, to the west. So it's going to be 10 kilometers per hour minus uh, oh, yeah, minus 50 kilometers per hour,
So it's
which
because
is going
of
to be, yes, 60 kilometers per hour.
okay, which is positive. So that's to the east as we are given
East.
directions there. All
Yes,
right,
sir.
so that is the major part that we are simply having. So it is important that you consider that part in that manner. It is very, very, very important. What about the first part of our question on that activity? I want us to consider this type of a question. What is happening here?
Okay.
So on this one, how can we attempt this type of a question?
Okay. A man traveling, oh, sorry. A man on a train. is walking to the back of the train at a speed of 2 meters per second, while the train is moving forward at 10 meters per second. So it says calculate the relative velocity relative to the man's velocity relative to the train. So we're going to do something, it's the same thing that we've been doing. It's going to be VMT
So
is
the
equals
velocity
to
of man
V man.
relative to the train, all right?
Yes, man relative to train. So our man is going to the back, so it's -2
The man
plus, oh,
going
negative,
back, so it's -2.
yes, back. Yes,
Hmm?
-2 minus 10.
-10.
Because our, yes,
From
wait.
this one.
Yeah, we have to, aren't we supposed to continue? Because the train is going forward. So I'm thinking of, okay, let me just say VMT is equals to VM minus VT. That's the first thing we're supposed to do, right? And then we substitute our,
Uh, all
go
right.
ahead.
In a normal sense, yes, it was supposed to be like that. If you are outside of the train,
Oh, okay.
you
So
are
this is a different
outside of the
condition.
train, you are on your own. But since the man is inside the
In
train,
the, okay.
it means that movement that is because is inside of the train. So the
Yes.
movement that is we're having, that movement is of the man relative to the train.
The train. Oh, oh, because he's inside the train.
Yes, because it's inside. The man is inside.
Mm,
So the one that we consider of the train, because the train is the one that is carrying the person, so the train has to be considered to the what? To the ground.
okay.
So this is the one they are asking the train's velocity relative
So
to the what? To the ground, which is the
VTT.
actual velocity of the train that we are given there.
Yes.
Yes, we can
Oh,
use our
okay.
VT minus what? Our minus VG, which is the same as what? Actual that we are given, the 10 meters per second.
Okay.
Since it is moving forward, it is supposed to be what? Positive.
Yes.
So this is the condition when you're answering this type of a question. When you are inside the train, whether you are moving to the back or to the front, the sign is going to be considered. If you oppose, it will be a negative to what you are opposing. If you are moving in the
Mm-hmm.
same direction, it maintains that direction that you are given there. But the condition is that you are inside of the train. So that movement or the speed that you be given is the one of you with respect to the train.
Yes.
Then,
Okay.
all right, are we together on that part?
Yes, I understand, sir.
All right, then the train, since it is the one that is carrying the person,
Mm-hmm.
we have to determine the velocity of the train with respect to to the ground.
Yes. Train.
So that is the condition. But now they want us to have the man's velocity relative to the ground, the man that is inside of the train.
Mm-hmm.
But they want us to have relative to the ground. What are we going to do now? Which is
Okay.
they want us to have the actual velocity. Now when it is like that, referred to the ground, not to the train.
Mm.
What are we
Are
going
we
to do?
so, are we supposed to manipulate the first one?
That is where we're
Maybe.
supposed to work with our formulas and see where we
Yes.
can have what? The man relative to the ground. Which
Yes.
one are we going to take?
G is equals to,
Which can contain this or which? Remember, when we have with respect to the ground, it is the same as we are having what? VM.
yes.
So it is important
Okay.
to target where we have either the ground or where we have M any part. We can work it from which one?
Because we know that the first one, A.
We know the first
If
one.
because okay, I should feel like I'm guessing. Because we know that for VMG, G is going to be equals to 0.
Mm.
Uh because here, okay, it's VT. It's the B focuses on the train alone. That's why I initially picked
What
MT.
VMT? Okay, from VMT, how can we work it? It's not as long with a formula there. How can we make it the subject? From VMT, it's gonna be what? From this is the from VMT, you're gonna have what? VM minus what? VT.
Yes,
So are we having VM? VM is the one that we need because it is the main to the ground. Is that so?
yes.
So this is the one that we want. What about VT? Just like VM, it means VT is same as what? VTG. Is that so?
VTG.
Respect to the ground. So
Yes.
we have it.
Mhm.
So you can make it the subject. Yes. So VM is there. VM is going to be equal to what? We're going to take this one to the other side.
Yes, VM is equals to VMT plus VT
Plus VT, whereby VMT
is -2.
-2 plus VT,
It's 10.
which is the VTG that we are given there.
Yes,
Okay.
which equates to 8, which meters per second.
Just like that. So that's our VM, which just simply means VM with respect to the what? To the ground. The main with
Yes,
respect to the ground. So that's how the questions can be given of someone who is inside of a train. These questions, they are very, very important to consider, actually. I want us to see this part here. It is a similar consideration or a similar thing where they consider someone who is inside of the train or anything that can be considered as long they can be a movement to say another part is going this way and you are going this way, or you can be in the same direction.
yes.
I want you to consider question number 8 of that same activity. Oh,
Oh,
yes.
question number 8. Let me go down. Yes.
So if we consider question number 8, what are we given there?
Okay.
That activity this time. Can you assist me to answer this one?
Okay. A man on a train walks to the front of the train at 2 meters per second while the train is moving at 15 meters per second. What is the man's velocity relative to the ground? Okay, so let me quickly write down 8. We have the, okay, wait. We have the VMT as positive 8. Wait, is it positive 8 or positive 2? Sorry, yeah, positive 2
The man
because
with
it's
respect
he's
to
to the train.
man on the man, okay, walks in front of the train. All right, so it's positive too.
Yes, it's positive 2. And velocity of the VT is going to be our positive 8.
VT, which is the velocity of train with respect to the ground.
Yes, VT or also known as VT or also known as VTG. So we are looking for the man's
Positive 15,
velocity.
why?
Excuse me?
Why is it positive 15?
Oh, wait, let me quickly. Yeah, while the train is moving forward, the keyword that I highlighted was forward
Exactly.
because the man is moving to the front
Okay.
of the train, and the train is moving forward
So both
at
are in the same
15.
direction, this one. All right.
Yes. Then
Okay.
we're going to manipulate the formula for
Calculate the
Vm.
man's velocity with respect to the what? To the ground. What are we calculating there?
Yeah, calculating Vmg, or also known
MGO.
as Vm.
Okay.
Yes.
So
Right.
from where?
To the ground. Yeah, the ground.
Okay, I
So
mean,
we're going to,
gonna take it
yeah.
from which one? From
Oh, VMT.
VMT. Okay, from VMT, we understand that VMT is equal to VM minus what? VT.
Yes.
So meaning to say at the end, VM is equal to what? If you take this side,
It's going to be 2 minus 8. Sorry, not 2 minus 8. I'm making a mistake. It's going to be Vm is equals to VMT plus VT.
plus VT.
Yes, so it's going to be 2 plus 8, which will give us 10.
8. Where are we
Oh,
getting
so not 8, 15. Sorry.
15? Oh,
Yes, sorry.
no problem. So it's gonna be 2 plus 15, which is what? 17.
Yes.
Are we told the direction?
Yes, forward. Oh no. Yes, the direction of the man is forward.
So just consider forward there. It's just positive, no problem when it is like that. And
Yes.
that is the case that we are having there. So I want you to go through as many questions as you can on this part. Then we can see where the challenges are. But we can see that as long we've got those other examples that you see there, they're just similar to, I mean, the other questions on that activity are similar to the examples that you have, that the first example. So if you go through those examples and you see if there's any part that is challenging, you will
Yes.
let me know.
Okay, no problem. This is page 9.
All right, so gonna try this one. It's an exam question. Uh, Let us see what is happening on this one. What can we do? What is happening?
Just give me a second. Okay, a steam train is traveling uh, due, due north at a velocity of 19. So 19 meters per second north. A woman is walking from the back of the train to the front at at velocity 1.9 meters per second. So, okay, we know that our velocity of the woman, so W to train, is 1.9 meters
The
per
velocity of
second.
what? The woman to the train.
Woman to the train, yes,
Mhm.
is 1.9. And our velocity of the
Why
train is,
1.9? Why not negative? Why positive?
oh, okay, so the keys that the words that I've highlighted is that she was moving from the back to the front. So she's moving forward. That's why I initially picked positive.
So
And
it's
also for the train, the reason why I picked positive is because north is always represented as positive,
just like that.
right?
Just like that.
Yes, sir.
So this is the velocity of what? The train.
Yes.
Relative to the what? To the ground. Or you can just write VT,
Yeah, PT.
which is what? 19 meters per second.
Yes.
All right, then from there, it means we can have the question, the velocity there of the woman's velocity relative to the what? To the ground.
Yes, we can. We're going to use VWT is equals to VW
This
minus
one.
T. Then we say VW
V
is equals to
VWT is gonna be VW minus VT.
VW. Yes, VW minus VT for VWT. Yes.
Okay, then we can find by tracking this to the other side.
Yes, sir.
So the woman with respect to ground is gonna be VWT plus what? Plus VT,
VT. Yes,
of
sir.
which we have got this VWT plus
19.
VT 19.
Yes, sir. So it's 19
So
plus
that will be
1.9.
29 meters per second. So this one, I
Yes.
want you to check it properly because on the exam there, they made an error on the calculation.
Okay.
And that's the most boring part of our science info. Still needs time, like the others, like the people that are working on it, like they have a
They're
lot
not
of
doing the
errors.
things. Yes.
So
Because when I'm revising, it becomes challenging because I see different answers and then I get confused and then I start doubting.
yes, it's like that in
Yeah.
most cases. So it's not a problem. We'll see. We are going to work out
Hmm.
um as many questions. So let me try to work out on these textbooks, then we'll see what we can do.
Okay, sir.
I'm going to send, since you have got that one, now let me prepare. I'm gonna send you the link for engineering science.
Yes, that's not a problem.
Um, so that you can download. Also, I think I'm gonna check the info. I think I have the answers, but they are for that
Hmm.
one. The TVET series, that one, some of it I can, then we see other ones because we
Yes,
also
sir.
need other textbooks so that we can use as reference. Question papers, I think that can help.
Yeah, I have the apps for question papers, so that's the question papers aren't a problem. It's just that one book. Mhm.
Yes, especially for, yeah, for question papers, we check if there's any part that is not clear. Let me know, because especially each question papers, you find out somehow something differ from what you learned. It can be like that. Those errors are there,
Yes,
so you need to work on that and see where it is happening. All right, I don't
that's
know if
not a problem. Oh, let me.
okay.
Yes, sir. I'm listening.
You let me know on that one if it is having a challenge.
Yes, it's not a problem. It's
Uh,
not so bad. I feel like I just confused myself.